Welcome. We're on 8-7, multiplying and dividing square roots. The idea here is, like powers, square roots distribute over products and quotients. So product of the square roots property for all negative, non-negative real numbers a and b, the square root of a times the square root of b is equal to the square root of a times b. And for all positive real numbers a and c, the square root of c divided by the square root of a is equal to the square root of c over a, or c divided by a. This is helpful as we're trying to simplify problems, and certainly as we compare roots, it's good to know that these properties can work. So let's take a look at our first activity, which is going to allow us to take a look at the square roots, product of square roots property. There's a pretty extensive table here to fill out. You could use a spreadsheet to do this. You could use lists in your calculator, or you can just go through and do the calculations yourself and fill them in to get your results. So why don't you go ahead and do that. I'll just erase this stuff here while you're working on that. Give myself some room. You can tell me what to write, okay? Okay, it did say to thousandths, right? To the thousands place, tenths, hundredths, thousandths place. So do that accordingly. It may not be quite the same for everybody. Be careful of your rounding. Make sure to round up when you should round up and round down when you should round down. Okay, well, some of these I'm pretty sure I know. Square root of 4 is 2. Square root of 9 is 3. The square root of 16 is 4. I think that's all that I know off the top of my head. Oh, we did root 5 in the last lesson. It was 2.24, but it was actually 2.236. And for 7, it's 2.646, 2.828, 10. Okay, long silence, but I've got my table filled out. Hopefully you've got yours done as well, because we're going to need this information to complete a couple of activities here. It asks us first to consider the product of the square root of 2 times the square root of 3. Find the product of the decimal approximations rounded to 3 decimal places. So the products rounded to 3 decimal places was for root 2 1.414, and for root 3 1.732. And is this decimal product found in the table above? Is there a place where we find a 2.449? And the answer is yes, at root 6. And so if so, write the equation that relates the product of the square roots. And we know from the property we were looking at that indeed that the square root of 2 times the square root of 3 is equal to the square root of 2 times 3, which is equal to the square root of 6. Okay, so we have shown our product of square roots property. Gives us the kind of result we expect. Let's explore it a little bit further. So to repeat step 2, but use a product of 2 different square roots from the list below. So we can choose a couple of things. You might choose something different from what I would choose. Once you go ahead and do that, do the calculation, fill in the blanks, and see what you come up with. Okay, so what did you choose for your square roots? It's oh, you chose 2 and 4. Okay, so root 2 times root 4, and I had my decimal approximations, 1.414, and root, oh, that's 2, wow. And so 2 times that would be 2.828. Is the decimal product found in the table above? The answer is yes. Oh, wait, table above. Table above, okay. The answer is yes, it is. And if so, write the equation that relates the product of the square roots. So we'll get rid of that. Relates the products of the square roots, and we find that root 2 times root 4 equals root 2 times 4 equals square root of 8. Multiply another pair of square roots in the table, any of them, and predict what their product will be. Is your prediction correct? So if you were to choose anything, let's say root 2 times root 7, we should conclude that this is going to equal to root 14, and that their approximations would be close. So that helps us get through this idea of the roots being, that the product of square roots property applies, and we can apply that routinely. We're now going to look at the quotient of a square roots property, which tells us that the square root of c divided by the square root of a is equal to the square root of c divided by a. Let's take a look. So pick a square root from the table. Go ahead, pick one, any one. And we're going to find that we're going to pick a couple. I'm going to pick root 6 divided by root 2. I'm going to get a decimal approximation for this value. So decimal approximation is for root 6 is 2.449. For root 2 is 1.414, and it's approximately 1.732. Is this quotient found in the table in activity 1? The answer is yes, and if so, write this as a square root. So 1.732 is root 3, and that's the square root of 3. And it said, if not, is it close to a number table, and what square root is it closest to? Well, it depends on how we came out here. I didn't choose anything that would get me there, but we repeat the process in step 1 using a different square root from each group. So let's try well, let's see, how about the square root of 18 divided by the square root of 3. Just see what we get. So that should tell us that this is equal to the square root of 18 over 3, which equals the square root of 6. But let's see if the decimal equivalents, how they work out. So the square root of 18 is 4.243 divided by the square root of 3, which is 1.732. And what does that give us? We'll do a quick 4.243 divided by 1.732, and that equals 2.450, rounded to the nearest. And that doesn't quite hit, but the closest thing, what it's closest to, so I should do an approximate, what it's closest to is 2.449, which is approximately equal to root 6. So we see we can get very close, and we can estimate it from that point. That's activity 2. And again, this is the idea of the quotient of a square root's property is for all positive real numbers, a and c. Root c over root a is equal to the square root of c divided by a. Okay, now we're going to look at another concept with radicals, which is to simplify them. You'll often be asked in a problem to simplify a radical. And in simplifying a radical, we need to factor the radicand. The radicand is the value within the radical. So in the case of example 1, the radicand is 50. The radical is the square root of 50. And to simplify it is to find its prime factors and see what we can pull out from the square root sign. So 50 is 2 times 25, and 25 is 5 times 5. So that means that I can rewrite the square root of 50 as the square root of 2 times 5 times 5. And 5 times 5 is 5 squared, and 5, we know that the square root of 5 squared is 5. We also know we could rewrite this as the square root of 2 times the square root of 5 squared, which means that square root of 5 squared is 5 times the square root of 2. You'll notice I moved these. I put the 5 in front of the square root. This is our convention in writing something in simplified form, where 5 is the coefficient of the root, and this means 5 times the square root of 2. That's our simplified form for the problem. Now let's take a look at our guided example 2. Guided example 2 asks you to, for the triangle here, find the exact length of the hypotenuse, and then put the exact length in a simplified radical form. So we use the Pythagorean theorem to say that c squared is equal to 7 squared plus 7 squared, So 49 plus 49 is 98. Use the radical sign to write the exact answer. And the exact answer is the square root of 98. Now use the product of square roots property to simplify the result. Note that the perfect square 49 is a factor of 98. So 49 is a factor. 2 times 49 is 98, so the square root of this, and so the square root of 49 times the square root of 2, and we know that the square root of 49 is 7. It factors to 7 times 7, and so our exact answer is 7 times the square root of 2, or 7 square root of 2 centimeters. We've now put this in a simplified radical form. One last two more examples. Example 3, assume x and y are positive and simplify the square root of 48x squared plus y squared. This guided example is on page 501. It breaks it down for you a little bit. Can look at this as the square root of 48 times the square root of x squared times the square root of y squared. Well, I know what's going to happen with the x squared and y squared. That's just going to give me x and y. Need to figure out what's going on with 48. And 48 is, let's see, something. I could factor that, right? So this is going to be 3 times 16, and root 16, so that's 3 times 2 times 8, and that's 3 times 2 times 8 is 2 times 4, and 4 is 2 times 2. 2 times 2 times 2. Okay, so I've got my factoring for this, and that's going to be times x squared times y squared. And so I'm going to have x times y times, this is 2 squared. I can pull out a 2, that's another 2 squared. I pull out another 2. 2 times 2 is 4. And that's now times the square root of 3, which is left over. Let me rewrite that in a more conventional form. X times y. 4 times x times y times the square root of 3 is our simplified form of the square root of 48x squared y squared. You've got a little bit different version in the text. You might find it simpler than what I've done. You're welcome to choose any method. One last example is a pendulum problem. The formula for the pendulum is given on page 501. You'll see a clock. Look for the pendulum formula close to the clock. At the Fermi National Accelerator Laboratory in Illinois, there is a pendulum hanging from the high ceiling in the atrium of Wilson Hall. The approximate length of the pendulum is 240 feet. What is the time P for one period of the pendulum? Well, we'll take a look at our pendulum formula. So this tells us that P equals 2 times pi times the square root of L over 32. we can plug in some values here. So we get our period is equal to 2 pi times the square root of 240 divided by 32. So P equals 2 times pi times the square root of, let's see, 7.5, 7.5. Okay, well, we kind of have our exact answer right there, but that doesn't help us. If we want to know how many seconds, this is in seconds, that's not going to help us much. We have a couple of things that are not conducive to an exact answer, which is the square root of 7.5, and also pi is an irrational number. So we're stuck with this if we're asked for an exact answer. But when we talk about time, we can approximate it generally, and we'll approximate this to the nearest tenth. And so in this case, we'll have 2 times, remember to use your pi symbol, not 3.14, 2 times pi times the square root of 7.5, and that tells us that the period is approximately 17.2 seconds. This would be our street answer. This is our exact form. Remember, when putting in pi, to use the pi button on your calculator. Do not use an approximation unless you have been told to do so. That's it for 8-7. I hope it was useful to you. We'll be getting on to 8.8 next. Good luck on the mastery quiz. See you in class.